Hello, welcome to Pomodoro Joe for Monday, October 16th, 2023. Today we're looking at LeetCode problem 119, Pascal's triangle 2. This is an easy problem. Oh, thank goodness for easy problems. All right, so given an integer row index, return the row indexed 0 indexed row of the Pascal's triangle. In Pascal's triangle, each number is the sum of the two numbers directly above it, as shown. So we start with 1, then we have two 1s. Now these each only are 1 because you have to look up to the left and up to the right, which just gives us 0 essentially, plus 1. And in this case, it's 1 plus 0. And then down on the third row, we have 0 plus 1 is 1, but we have 1 plus 1 gives us 2, and then 1 is 1 plus 0. Okay, so let's put 25 minutes on the Pomodoro timer and we will get started. So this is pretty straightforward. We'll just approach this in the very straightforward manner. We'll have an index and we'll keep advancing our index when we'll calculate each row at that index until we reach this row index. So we'll start with our index and that will be index 0. And we'll start with our initial row and that will be an array or a list with just 1. So as you can see, index 0 just has 1. So that's our starting case. Now, while our index is less than or equal to our row index, so now we're trying to get to this row, so we're looking for our index to equal our row index. So while it's less than or equal to the row index, now we'll actually have to calculate our row. So I'm going to actually, before I forget, I'll make sure I advance my index here. So index plus equals 1. That way we don't end up in an infinite while loop. Okay, now before we get there, what do we need to do? Well, let's keep track of our previous row because we'll need to look back at our previous row to calculate our current row. So we'll have our previous row, and that's just equal to this row. And then we have our new row, so we'll have some new row, and again we can start it with 1. All right, so we store our previous row, we create a new row, we start it with 1. As you can see, every element on the left-hand side of every row will be a 1. So we'll just start our new row with 1. Now we have to go through every element in our new row. So for every index, I already used index, so every I in range. Now we're not going to start at 0 because we've already filled this first element with a 1. So we'll go from 1 to, and let's see, how many numbers or how many elements are there going to be in this row? Well, it looks like at index 0, there's 1 element. At index 1, there are 2 elements. Index 2, there are 3 elements. So the index kind of tells me how many elements there will be. So it's going to be index plus 1 elements. So we'll say index plus 1. Again, index 0, 1 element. So that 0 plus 1 is 1. Index 1, 2 elements. 1 plus 1, 2. So that gives us our index plus 1. All right, now we actually have to figure out our values for each one of our elements. So for this, I'm going to look at, well, it looks like I need to look up and to the left, and then I need to look, well, I guess up and to the right. Now, if we look at this number 2, this gives us the best example. This number 2 is at index 1, so that's 0, 1. So for index 1, we have to look back at index 0, and we have to look up at index 1, so that's the same index. So it looks like we have to look at our index minus 1 and our index at the previous row. So let's see, I'll have some value here, and that's just going to be our previous row at our index minus 1. And then it's tempting to say plus our previous row at this index. So again, if we look at this number 2, it's at index 1 because we go 0, 1. And it's going to be an addition of the previous row at index 0 and index 1. So that's index at its index minus 1 and its index itself. This works well for most of our elements, but it's possible, and well, it's in fact very likely, that this index, this I, will be out of bounds because we only have 2 elements in our previous row, at least in this first 3 rows. If we're looking at row number 2, Again, 0 index, that's 0, 1, 2. There are 3 elements in this row, but only 2 elements in the previous row. So if we were looking at our third element, now we're going to end up out of bounds when we look back at our previous row. So we actually have to make sure that we're not going out of bounds. Now I'm starting with 1 here, so I can definitely look backwards at I minus 1. I'm not at risk of going out of bounds there. I am at risk of going out of bounds at the upper bound, so let's do a check here. All right, we'll say if this index is less than the length of our previous row, then we know we're not out of bounds, and then we can add our previous row at this index to our value. So this will be val plus our previous row, or plus equals our previous row. So that's the value plus the previous row. So now that we have our value, we need to append this to our current row. So this is going to be row.append this value. All right, that pretty much takes care of it. Once we go through all of our rows at the very end, after we get done with this while loop, we'll have the row at this row index. So we can just return row. All right, so let's try this out, see how it goes. All right, seems to work. Let's submit this, see how we do. All right, and we do pretty well, actually. No, we don't. Well, we pass, and we beat 23% for runtime and 96% for memory. So we do great with our memory, not so great with the runtime. Now, what could we do to make this better? Well, one thing we could do, well, no, that doesn't. I was going to say we could convert these rows to tuples, but I actually don't think that's going to save us anything. Let's see, what could we do here? I don't really see a lot of ways to really improve. I mean, I'm sure there are. Let's see. Let's take a quick look at how other people are solving this. Oh, I see. Some people early out, they already check, oh, if this is row index 1, I already know the answer to that. That's okay. It saves us a little bit of time. Let's see, this is interesting. This is sneaky. So what they're doing here is they're actually adding a 0 on either end. So where I have to do this check, let's see where, let's go back out here. I'm checking here if we're out of bounds. What they're doing is they're just adding an extra 0 to the end of the previous. They're actually adding 2 extra zeros, one to the beginning of the previous row and one to the end of the previous row. And then they can just do the calculations without having to do these bounds checks. That's pretty smart. Anyway, that's all I have time for. I know this is a short one, but I hope you enjoyed it. I hope you had fun. I hope you learned something. I hope you can go out and write better code.